Hello, this is the first video of the Algorithm 1 series for OCR AS Discrete Further Maths. It provides an introduction to algorithms and flow. An algorithm is a sequence of logical instructions that will solve a particular problem, giving a unique output. There can be no ambiguity in these instructions. In addition, the instructions must work for any input and have a finite number of steps. Importantly, there must be a step or instruction that terminates or ends the algorithm, otherwise a person or computer might become entrapped in a loop. Whilst we'll be only looking at trivial examples or small-scale problems in the videos, you should understand that similar methods are used for large-scale problems that are solved by computers. You will all have been using algorithms for years without possibly realizing this. For example, recipes, long multiplication and division, setting up your mobile phone using instructions. Algorithms can be written as text, as a flowchart, or in pseudocode. Simple pseudocode is covered in the next video, 1.2. It is a cross between English and computer syntax. Examples of algorithms written in text will be given in later videos on bin packing and sorting algorithms. Flowcharts have conventions for the box shapes used. Boxes with curved ends or ovals indicate the start or end of a process. Rectangular boxes contain instructions to be carried out, whilst diamond-shaped boxes contain questions, and the route out depends on the answer. Let's look at an example. Here we are starting and inputting three numbers, A, B and C. D is then defined as b squared minus 4ac. You may want to pause here and think about whether this seems familiar. The question is then asked, is d greater or equal to 0? If the answer to that is no, then the output becomes no real solutions and the loop takes you down to end. However, if the answer is yes, then e is defined as minus b plus square root of d, all divided by 2a. F is then defined as minus b minus the square root of d, all divided by 2a. The outputs are e and f, and only then do we end. In terms of seeing what this flowchart does, you may have recognized that this is an algorithm for the quadratic equation, where d is the discriminant. The outputs are either two real roots or solutions, or the phrase no real solutions. If you wanted an option of an output saying one repeated root, then how would you manage this? Well, you might add an extra loop. For example, if you had a question box, d equals 0, then if the answer to that was yes, this could lead to an instruction where g equals minus b over 2a, or divided by 2a. And then to have output one repeated root g, which would then link in back here to the end. Otherwise, if it was no, you could continue down at this point to say, is d greater than 0? This should then give you those three options of no real solutions, one repeated root giving minus b over 2a, or the two outputs for two real solutions, E and F. If we set A equals 1, B equal to minus 2 and C equal to minus 8, we can then trace what happens. So with an input of 1, minus 2 and minus 8, we would then have for D equaled 4 plus 32 equal to 36. D greater than or equal to 0 would be a yes, and then E would be 2 plus 6 all over 2 equal to 4, and F would equal 2 minus 6 over 2 equal to minus 2. Therefore, the output would be 4 and minus 2, and then it would stop. For the input, A equals 1, B equals minus 2, and C equals 5, that D equaled minus 2 squared minus the 4 times 1 times 5, which in this case is minus 16. So therefore the output D greater than or equal to 0 would be an answer no, and you would have the output of no real solutions. For those of you who have already covered complex numbers, note that this flowchart could be amended to deal with complex conjugate solutions. You may wish to pause and consider this for yourselves. It is often useful to have a table to trace a flowchart. For example, if we input n equals, and then in this case that b equals, then we would have that a was not greater than n, which would lead us to output b, which is a 1 in this case. A would then become a plus 1, becoming 2. B would then be a squared, which is 4, and the output of 4 would be given. We will continue around the loop with A becoming 3, B 9, and an output of 9, A 4, B 16, an output of 16, A 5, B 25, and an output of 25, A 6, B 36, with an output of 36, A 7, B 49, and then because at that point A is greater than n, it would end. This algorithm appears to have all the outputs of the squared numbers up to and including the value of n. In the next session, 1.2, we will look at some algorithms written in pseudocode.